Okay, I think we're up and running. So, not sure how many people are here. And the stream seems to still have a delay, even though I clicked the new setting that says it would make for real time feedback. Oh, maybe the delay's only 10 seconds now or something. So I guess that works. Okay. Let's see who's here. Anybody? It said there were 5 people waiting, but I'm only seeing one. Aha. Well, we for sure have one person, so we're in business. While I wait for a question or two to be requested here, I might uh, pop over to the practice paper. So the practice paper that I uploaded for everyone to look at, this is actually last year's mock exam. Um, and I went looking for my solutions from last year and can't seem to find a digital version. So right now, if you look at the solutions tab, you're just going to see a blank copy of the exam. There's not a whole lot there. I will go about filling that in tomorrow so that people have that to reference. There may even be some people who request looking at some of these questions this evening. I don't know. And so if there are, then I'm just going to write it up on the exam itself. Um, and then the solutions will be there for anyone who comes looking after. I don't know how I don't have digital solutions for this exam. I thought for sure I would have, but I can't seem to find them anywhere. So I must have scanned them and then sorted them into the wrong folder. But rather than looking, I'll just start from scratch. Uh, so I think one thing I will do is go and take a look actually at probability distributions test. There's a question here that someone was asking me about, not the egg question. Yes, I think it was this one, number 6. So I'm going to just take a quick screenshot of that, and I'm going to pop that over into here and go through it. I know Roman was asking me about this one for sure, but he's probably not the only one. It's one of the tougher concepts from probability distributions. So this is question 6 from that test. The marks M of a mathematics exam at a large school were normally distributed. Let mu be the mean and sigma be the standard deviation of the distribution of the marks. Given that 10% of the candidates that sat the exam scored at least 82 marks and 20% scored less than 40, find the value of the mean and standard deviation. And so in this particular problem, I have a random variable, which has been defined for me as M, and I know it's normally distributed, but I don't know the mean. I don't know the standard deviation either. I am given some information about probabilities related to this random variable, so I know that the probability that a randomly selected mark is greater than 82 is 10% or 0.1. And I know that the probability that a randomly selected mark is less than 40 is 20% or 0.2. And so that gives me the opportunity to actually go and use my inverse normal distribution, figure out what the z-scores would be for a data value that's yielding these probabilities. And so again, the z-score is how far away from the mean your data happens to be, measured in standard deviations. So if my z-score is 1, I'm 1 standard deviation above the mean. If it's negative 2.5, I'm 2.5 standard deviations below the mean. And so I can use this information to solve backwards for z-scores, and then use that to actually figure out the mean and standard deviation, because it's the same mean and standard deviation for both of these. So I really just need to figure out what that connection is. And so the way that you do this is on your calculator, you're going to press the second function key and then the vars button. That's going to get you into your distributions menu. And you want to select option number 3, which is your inverse norm. This is, again, working backwards from your normal distribution. And it's going to prompt you for the area and then the mean and standard deviation. Now, you're going to want to leave those as 0 and 1 in this instance, because we don't actually know the real mean and standard deviation here, so we have to use the standardized normal distribution, which we always use as z as our random variable there. And that's the normal distribution where the mean is 0 and the standard deviation is 1. That one strictly tells us z-scores, so we know how far above or below we're at. So using that, I can fill in the probability in the section that's marked area, and then that's going to give me the z-score. So if I take this, I'll number off these values, 1 and 2. So basically what's happening here for situation number 2 is that 40 is somewhere over here, and so the area that's less than that is 20% of the data, or 0.2. So if I put that in as my area, 0.2, that is going to give me a z-score for this one that is negative 0.84162122335. You don't have to actually write out all the digits. It's going to be saved in your calculator anyway. For this first one, it's saying that 10% is actually above a certain amount. So we're basically looking at 82 being up here, and then this is the 10% that's above that value. Most calculators are only going to do to the left of the value. Some calculators, for example, if you had a Casio calculator or potentially a TI Nspire, you can actually choose the direction of the tail, it's called, and so you can actually tell it whether you want it to go left from that value or right from that value. By default, the TI-84 series of calculators, they all go left. And so in this situation, knowing 10% is above, I actually need to realize that 90% is below that value, and so 0.9 is what I'm going to use for my area. So I'm going to go back into inverse norm. I'm going to enter in 0.9, and that's going to give me a z-score, which should be positive, and it is. I get the z-score is 1.281551567. And so knowing these z-scores now, there's this relationship between the values themselves, the x values, the mean, the standard deviation, and the z-score, and it's given by this equation, which is in your formula book. And so once I know the z-scores, and I already knew the data values, I can set up two equations here. So this one here is going to be 1.28 and change is equal to 82 minus the mu over sigma, and this one is going to be negative 0.841 ... and that's equal to 40 minus mu over sigma. And so at that point, it's just a matter of doing substitution or elimination to solve for those missing values. You've got two equations, two unknowns. It can be really straightforward to come up with an equation if you just sort of swap the positions of your sigmas and your z-scores, because then you've got sigma is equal to one thing, sigma is equal to another thing, so you can set them equal and solve. So I won't actually finish that one up. It is fully written out in the solutions, which are already posted on the OneNote, so this was more just to clarify what the thinking is behind that solution. As far as the actual number crunching, you can see the solutions that are posted for the rest. Because now I can see that I have two requests from people here in the chat. And so Hannah's asking for 230, number 5. And Donald is asking for 176, number 7AB. Okay, so I'm going to pop over to my textbook here and see if I can't dig up those questions. I don't know what topics these are, just based on the page numbers. 230 appears to be trig. So I'll screenshot that one in. I don't know if that was meant to be thematically appropriate, that Hannah has asked me to do a question about a family in Germany, given that her family has some German roots. And 176, Donald said A and B, but now he said actually just B. 7B. Oh, yep, got it. So we're into sequences and series here. Alrighty. The questions are coming out a little blurry because I'm using such a small version of the textbook. I'll fix that for my next screenshot. Okay. So we'll do this trig question first, and then we'll move on to the sequences and series. So, a family in Germany drives 140 kilometers per hour for 45 minutes on the bearing 32 degrees, and then 180 kilometers per hour for 40 minutes on the bearing 317 degrees. Find the distance and bearing of the car from its starting point. All right, so a little bit of trig here, kind of a little bit of vectors, maybe a little bit of physics, if perhaps we forget the relationship between velocity and displacement and time. And so really the main thing you need to know is this. We're actually going to be working with everything in distances, so I'm just going to rewrite this to be distance is equal to velocity times time. So I'll start by drawing a diagram here because I need to get a sense of directions. So we have, first we're traveling on a bearing of 32 degrees. So if there's my little compass rose to help me figure out where my bearing's going to be, if it's 32 degrees, that's only just a little over a third of the way through that first quadrant. So basically from here to here is 32 degrees. That's what that bearing represents. And then from that point, after they've finished going in that direction, they go on a bearing of 317 degrees. Which, as I read that, I realize I've left myself no room to draw the direction that this car goes. Let's move this picture way over here. I think that should work a little bit better. So I've got my bearing still of 32 degrees. The reason why I knew the 317 wasn't going to fit is because if I rotate around 270 degrees, that gets me from facing north through east, south, past west, which would be 270 degrees. And so 317 is somewhere in here. And so that's roughly the direction they're going after that last rotation. So it's 317 degrees to get all the way around to there. I think probably what's going to end up being the more useful angle is if I know that, oops, too much. If I know that direction, I'll just zoom in a little bit here. if I know that that larger angle all the way around is 317 degrees and a whole circular rotation is 360, that actually tells me that the angle between here and true north is going to be 360 minus 317. So we're looking at 43 degrees there. And so from this angle of 32 degrees up to this angle here, I know that this one is also 32 degrees, kind of tucked in under there because of the parallel line theorem. I've basically got two lines that are pointing perfectly north, right? And so if we say that this one is 32 degrees, then we know that this one is 32 degrees as well. And so what this gives me is actually an interior angle to what's going to become a triangle in a second. This angle here, which I just marked in purple, is 180 degrees minus those two other angles, 32 and 43. So this angle here is 105 degrees. And that's really helpful because that's going to give me a sense of the direction that things are going in this particular question. So now the piece that's missing is actually knowing the lengths of those sides. I'm given velocities and times, but what I really need are distances. So in that first leg of the trip, they go 140 kilometers per hour for 45 minutes, which is 3/4 of an hour. So what I'm going to do here is 140 kilometers per hour times 45 minutes, or 3/4 of an hour. And so if I do that, I'm going to get the distance that they traveled, which is 105. Interesting. 105 kilometers specifically. And then distance number 2, they went 180 kilometers per hour for, 40 minutes. So 40 minutes, so 40 minutes out of 60 is 2/3 of an hour here. And so that means that on that part, they went 120 kilometers. So if I go to start labeling distances now, and let's just pick a different color here. This distance here is the 120 kilometers that they travel, and this one down here is the 105 kilometers. And so if I am looking to know the final distance that they went, or the overall distance from their starting point, I am looking for this distance here from their starting point to their ending point, and they're asking for the bearing of the car from its starting point. And so I'm going to need to figure out that angle that's contained within. The way that this looks right now is a little bit misleading. It looks like they've gone perfectly north, and I'm confident that that's not what happened. So I'm just going to touch up my diagram a little bit here, make that go a little bit further. So that is their resulting distance. Okay, so that's the distance that I'm looking for. The bearing that I'm going to look to measure is likely going to be this one in there. So in order to find that distance I've marked in yellow, I'm going to be using cosine law. I have two side lengths and the angle in between them. So I'm going to do c squared is equal to a squared plus b squared minus 2ab cos c. Piece of advice, since we have not done trig in a little while. I guess it's shown up a little bit in vectors, but just make sure that you're very careful about what mode your calculator is in. You will be expected to reset at the start of any examination, both mock exams and actual IB exams. And you need to make sure that you don't then just blindly march through a problem, because you may very well end up with an incorrect value. And so when I go and do this calculation, subbing in my values 105 and 120, 2 times 105 times 120 cosine of 105. What I get as a value for C is 178.74, we'll say, kilometers. And so if I want to figure out the bearing, My best bet here is probably to use sine law at this point, um, because I have uh, a pair of an angle and a side. Oh, that was a terrible pen to use. Let's try that again. This guy. I have this pairing of an angle and a side, right? I now know that this is 178.74, roughly. And I want to find this whole angle down here. And I know that that pairs up with the 120. So to find the bearing, I am going to need to do sine, what do we want to call this angle? Let's call it beta. So sine of beta over 120 is equal to sine of 105 over 178.74. And so now if I go and solve for beta, beta is going to be sine inverse of 120 sine of 105 degrees all over 178.74. So I just did the rearranging. I didn't really show the steps there, but I just multiplied the 120 over to one side and then did sine inverse to solve for beta by itself. And so I'm just plugging that in now. This is obviously something that would be on a paper 2, because I would not expect you to calculate any sort of trigonometry stuff with angles that are very clearly not convenient special angles. And so this is the number my calculator gives me, which I'm going to round to 40.4 degrees. Now 32 of those degrees I'd already accounted for here in my diagram. If I zoom in, the 32 degrees of that 40.4 is right there. And so what that means is that this tiny little sliver of an angle is 8.4 degrees. Now, I can't have that be my bearing, because my bearing needs to be measured from true north and go all the way around. So I basically have this, something directly to the north, and I'm going all the way around and only leaving behind 8.4 degrees. So my bearing is going to be 360 degrees minus that 8.4. And so that's going to be my final answer. I'm basically looking at 351 and change, 351.6. And so that would be the final distance, 178.74 kilometers, which I got over here. And the final bearing was this one right here. Okay. So there's lots of trig questions and even vector questions that will ultimately end this way. I'm pretty sure there was one on the mock exam last year, which means there's one on the practice exam. I think it's paper 2, question 9. So after looking through this, get a sense of whether you've got a good understanding here, and then give that one a shot, because that'll be the real test to see whether you have wrapped your head around it. Moving on to number 7 from page 176. The request was for part B, and so in this question, they're very explicit about the fact that one of these sequences isn't arithmetic or geometric, and it's actually the middle one. So if you look at it, 3 over 4, 1, 7 over 6, 9 over 7, if you just look at patterns between those terms directly, you're not going to see anything. However, if you look at the numerators by themselves and the denominators by themselves, so numerator, denominator, we can maybe start to establish patterns within those individually. So in the numerators, I see 3, and then I just put a blank because I'm not going to put 1 over 1 there. There's obviously something more going on with that second term. But I see 3, blank, 7, 9. And so if I'm trying to see some sort of pattern there, it looks like between those two terms it's going up by 2. So perhaps I assume that this is arithmetic with a common difference of 2, and then this missing value here should be a 5. Well, if I'm going to operate on the assumption that that's a 5, and yet the term was written as a 1, it must be because the fraction it ended up resulting in was 5 over 5, which reduces to 1. So that seems to suggest that that number is also a 5. So hopefully that also makes some sort of sequence, and if I look at these terms, they all appear to be going up by 1 as I go along. So it looks like the numerator forms one arithmetic sequence, and the denominator forms a second arithmetic sequence. So if I were to come up with a general term for the numerator, I'll just call the numerator's general term un, and then I'll pick a different letter for the denominator. Let's see, our general term, we take the first term and add n minus 1 times the common difference. So my first term is 3, my common difference is 2, and so if I simplify that, I get 2n plus 1. So there's my numerator. My denominator then, let's use wn, I guess, would be the first term plus n minus 1 times d. So my first term is 4. My common difference is just 1. So that's going to tidy up fairly nicely because I get n plus 3. And so if I looked to come up with a general term for the whole thing, I can actually do that. What letter should I use here? Let's just use x. Why not? So xn is the general term for the whole sequence, and it's going to be un over wn, or 2n plus 1 over n plus 3. And then you can see how that actually works to give us the original sequence. If I look for my first term, I get 2 times 1 plus 1 is 3, and in the denominator 1 plus 3, which is 4. If I look for my second term, I get 5 on the top, 5 on the bottom, which is just 1, right? So it holds for everything. 7 over 6, which was my third term. 9 over 7, if I wanted to figure out a fifth term that was not provided to me. It would, in this case, be 11 over 8, right? And so that's an easy way to define a sequence that's actually a ratio of two arithmetic sequences. It's funny, I assign this question every year. It's always one that I find really, really interesting to solve as a problem, and yet I've never actually built on it, unfortunately, for an assessment. I've never taken that question and kind of spun it a little bit, maybe done a ratio of two geometric sequences or something like that. I don't know why I've never done that. And this is not even me being, tongue-in-cheek about the whole thing and saying that this is something on the mock exam. This is not a question I crafted for the mock exam. I'm just now wondering to myself, I get this question a lot. It's one that I find really interesting, and yet I've never built upon it, and I don't know why. It's very atypical. All right, so those were the two questions that I had requests for. So it says we've got 4 people here now. I'm not sure who there is. I'm assuming Hannah and Donald are still here. Hopefully that those solutions help them. And if there's anyone else, now would be a good time to state your request for a question that you would like to do. Page 342, number 7. Okay. Page 342. Come on, textbook. 342, number 7. And we're into vectors here. Very nice. Okay. All right, I'm going to take a screenshot of this. Unfortunately, oh, wait, maybe I can take a screenshot that doesn't take the other question. They really pack the vectors questions in this textbook. It makes that whole review set look very densely packed. All right, let's see how that screenshot worked. Okay, it looks ridiculous, but I didn't accidentally screenshot a different question. So that's what I'm seeing at 342, number 7. Review set C. Yes, okay, it is review set C. Perfect. So that is the right question. Okay, so we'll take a look at this one. Given the points A, B, and C, and they're all in 3 dimensions, show that AB is perpendicular to AC. Cool. And find the equation of the line through AB and the equation of the line through AC. Great. This is a great question. Part A and B build on themselves, or build on each other fairly nicely. So to show that AB is perpendicular to AC, I'm ultimately going to need to find those vectors. And then we'll talk about how we actually verify that they're perpendicular. So my first step is just legitimately going to be find the vectors. Even if you didn't know what your next step was going to be, this is a good first step. So I'm going to take the coordinates of B and subtract the coordinates of A. And so what I get here is -2, -1, and then this last one would be 6. And so here, AC, I have 9, 4, 1 are my coordinates for C, and then I have -4, -2, -1. Boom. And 9 minus 4 is 5, 4 minus 2 is 2, 1 minus -1 is 2. So fairly nice vectors to work with, thankfully, as I'm going to be using them for both parts of this question. So part A says show that AB is perpendicular to AC. Anytime you're dealing in vectors and you're working with the angles between them, especially if it's about them being perpendicular, your brain needs to immediately jump to the notion that you're dealing with a dot product. Now, if you're just checking that things are perpendicular, that's actually the easier scenario because you're only using the definition of the dot product that involves the components of the vectors. So you're taking the x components and multiplying them, the y components and multiplying them, and the z components and multiplying them. And if, in this case, AB is in fact perpendicular to AC, and it says show that, so we would assume that that's what this builds to. But if AB is perpendicular to AC, then the dot products of these two vectors has to be 0. Okay, so this is always the easier scenario when you're using the dot product. I would think this is the preferred scenario for most people, because the alternative is you need to figure out what angle is between them, and then you need to find their magnitudes and use the other way of finding the dot product too, which is, and I'll write this in a different color. It's not really relevant to this question. But there's the other way of finding the dot product, which is where you do the magnitude of A times the magnitude of B times the cosine of the angle between them. And basically what you end up doing in that situation where you want to find the angle is you have to actually link this definition of the dot product to this one. Now, thankfully, that's not what we have to do here. The only reason I'm bringing it up is because I have seen some people go and use the version that I've written in blue, even when they're told something is perpendicular. So if they're perpendicular, the angle between them is 90 degrees, and cosine of 90 degrees is always going to be 0, so that whole side's going to get wiped out. But what people end up doing is they waste a lot of time finding the magnitudes when they didn't need them. And so that's more the piece I'm trying to caution against, because if you spend time finding magnitudes of vectors, especially if it was, two vectors that maybe the magnitudes don't work out so nice because the numbers are just a little off, right? You could end up doing a lot of work and then realize you didn't need to do that work, or worse, you might not realize you didn't need to do the work, and then you've just spent a lot of time and it was for no helpful purpose. So here, I want to do the dot product of these two vectors, so I'm going to take the x components and multiply them, the y components and multiply them, and the z components and multiply them. And now I'm just going to evaluate. -10, -2, and 6 times 2 is +12. And so if my math's correct, that is equal to 0. So the dot product is equal to 0, so therefore AB is perpendicular to AC. Done. I don't need to write any long-winded justification of that. I've shown mathematically that the dot product's 0, therefore they're perpendicular. That's it. No writing sentences or anything like that. I wouldn't devote your time to something so frivolous. All right, so our next step is find the equation of the line through AB. A and B, and then the line through A and C. So I'm just going to call those line 1 and line 2. And I'm going to use very much the same rationale for both. If I'm finding the equation of a line using vectors, I express that equation as a vector r is equal to a position vector that gets you onto the line, and then you have to have a scalar multiple times a direction vector. And so if you recall in both the review class and the original lesson for this, my main messaging was this, that when you're talking about the vector equation of a line, the purpose of that A vector is to navigate you to the line. So you could be anywhere in the Cartesian plane or in three-dimensional space, but you need to find the line in the first place if you're going to follow the path that keeps you on the line. It's kind of the equivalent to the y-intercept being that fundamental starting point for lines in 2 dimensions when you first learned about them in grade 9. So when you first learn equation of a line, you learn slope-intercept form. And so we basically direct you to that y-intercept to say, here, this is a spot where you'll be on the line. And if you keep going along this slope, over 2, up 1, over 2, up 1, you're going to stay on the line as you keep going. So that's kind of the geometric way of rationalizing that. The same thing is true here with these vector equations. That vector A is the equivalent of your y-intercept. It's what directs you to the line. And then that vector B is the direction vector that keeps you on the line. So if I'm talking about a position vector that gets me from the origin to the line through AB, it could actually be the vector that gets me to either the point A or the point B. So the position vector of those points. And that's easy to find because it's just taking the coordinates of that point and writing it as a column vector. So I could use A, which is 4, 2, minus 1, or I could have used B and made it 2, 1, 5. It actually doesn't matter. And then I'm going to multiply it by a scalar multiple, and then I need a vector that's going to keep me on the line between A and B. And I already have that vector, conveniently enough. It's the vector from A to B. So I'm going to put in -2, -1, and 6 here, and there's my vector equation of the line that passes through A and B. And so if I do the same thing for my second line, I just need a point on that line. I could actually use A again here, which is pretty convenient because A is on both of these lines. And then I'll just take a different scalar multiple here and use the direction vector 5, 2, 2, which is the vector that passes through A and C. So I had all the information I needed. I just needed to assemble it into the proper form. And so that's the conclusion of that question. There was only 2 parts, the dot product, finding that they're perpendicular, and then finding the equation of the line. All right, so that's page 342, number 7, in a nutshell. A little bit of vectors there. Seems to be someone who's popping in and out of the stream, because the number of people watching keeps fluctuating by 1. So we've done a trig question, a sequences and series question, a vectors question. That's interesting. We're making our rounds through the topics. No functions questions just yet, and no statistics or a probability. Although I did start the stream off while I was waiting for some requests to come in with an inverse normal distribution problem. And that one was picked from our probability distributions test from the start of the year. All right. While people are sorting out what other requests they might have, I'm going to move over to the practice mock exam and just go through a few of those. Now, if you're someone who hasn't done the practice mock exam just yet, maybe go ahead and mute this. I don't want to spoil any of the questions for you. Also, there appears to be a typo on this. I'm surprised I didn't catch that. I must have caught that when I was marking. Oh, well, look at that. The next request that came in was actually about this practice paper anyway. Mock exam, paper 1, number 3. So this one right here. The following diagram shows a circle with center O and a radius of 10 centimeters. Points A, B, and C lie on the circle. Angle AOB is 1.2 radians. Find the length of arc ACB. Right, and then find the perimeter of the shaded region. Okay, so arc length is an equation that is provided to you. So when I want to find the length of a circular arc, I just have to take the angle in radians and multiply by the radius of that circle. So this is in your formula booklet. My angle in radians in this case was given to me as 1.2, and the radius was 10. So I suspect these numbers were picked very purposefully way back whenever this was drafted, because 1.2 times 10 is really easy to calculate. So the arc length there is 12. Now, if you're confused about the wording where it says the length of arc ACB, so there's two different ways to denote arcs. The first way is you can basically put a point on the arc and then use that in the naming of the arc. So arc ACB implies that this is the arc that goes from A to B passing through C. The other way that we did, if that point C hadn't been there, I taught you guys this terminology that because this is the smaller arc, we would refer to that one as the minor arc, and then the arc that goes the other way around to get from A to B is the major arc. And so it could say find the length of minor arc AB or major arc AB. And that's a possibility too. Anyway, so we figured out the arc length from A to B. And so then we're asked to find the perimeter of the shaded region. Now, this might seem like a daunting task, but if the shaded region was this one, I don't think many people would bat an eye. You guys would know it's the radius twice plus the arc length. The same is true here, even though you're actually looking at the major sector and not the minor sector. And so I am going to just find the perimeter by doing the radius twice, so 2 times the radius, and then plus I'm going to need to add in that major arc from A to B, so the bigger piece. So here, the easiest way really to do that, I think, is to just find the circumference of the whole circle and then subtract the arc that I know is not included. So the circumference of the whole circle would be 2 times pi times the radius, but then I'm going to need to take away 12, which is that minor arc from A to B. So the radius is 10, so 2 times 10 plus, and then 2 pi times 10 here, minus 12. And that's going to give me the perimeter of the whole region. So the 2r, this piece, is taking this, and then let's get a different color here. Oh, why is that changing the color of my number? This section here is getting me this piece all the way around. And so if I go and evaluate that, oh, and this is on paper 1, so you wouldn't have a calculator. So this is even easier to evaluate than I was thinking, because I don't need to actually plug pi in. I have 20, and then minus 12 in that set of brackets, so I'm going to end up with 8, and then plus 20 pi. And so that's the perimeter. I would just leave it as that. Our units are centimeters, and that's fully simplified at this point. All right. So that is the practice paper number 3. So I'm just going to rewind a little bit while people maybe gather together their other requests. And I'm going to go through the practice paper starting at number 1. Oh, now I see why the marks doesn't add up, because it goes on to a second page. Wow, I do not remember this mock exam at all, apparently. All right, so question number 1, section A, starts with a quadratic. Write down the y-intercept of the graph of f. Easy. Sub in 0. I'm left with a -6. Done deal. And then my next step is solve for x when f of x equals 0. So that means I'm solving x squared plus x minus 6 equals 0. So I'm just factoring x plus 3 times x minus 2. So x equals -3, x equals 2. 3 marks, done. And then I move on to the next part where it says, on the following grid, sketch the graph of f for the domain from -4 to 3. So I've got x-intercepts already at -3 and 2. Right, I found that in part B. I know my y-intercept is at -6. And so if I'm looking for where my axis of symmetry is, it should be right there, directly in between the two x-intercepts. So that tells me I have another point that's right there. And so then, I mean, I can really go about finding other points if I wanted to. So if I plug in 1, I get 1 plus 1 minus 6, so -4. And by symmetry, another point is going to be right over there. And so I'm starting to get a sense of the shape of the quadratic. So it's going to look something like this. And like this. And so the question is, where's that vertex in the middle? So if I can plug in -1/2 and evaluate. If I do that, f at -1/2, I get 1/4 minus 1/2 minus 6. So 1/4 minus 1/2 is -1/4. And so if I want to convert this into a decimal just for my own peace of mind, it's -6.25. So we're really looking at a vertex that's kind of right about there, which is more or less what I would have expected based on how the graph was shaping up. And there's my quadratic. It was a little lumpy around the y-intercept, but I think you'd be able to draw a smoother curve if you were doing it on paper than me doing it on an angled screen right now. On to question 2, we've got a binomial. Oh, no, not a binomial situation because it's without replacement. So this is just a dependent probability situation. A bag contains 5 green balls and 3 white balls. 2 balls are selected at random without replacement. And I need to fill in the tree diagram. So a lot of people in the review class expressed some reservation over having to do dependent probability questions, which I get because there's some complexity there, but this is the kind of thing that shows up pretty often on IB exams as far as dependent probabilities. They sort of establish, okay, here's a tree, here's the situation, can you fill in the tree and then do some stuff with it? And I think a lot of the trepidation about the tree diagram problems comes from the fact that people think they have to draw the tree from scratch. And so if you're not someone who's really comfortable with visually organizing information, that can be a hurdle. And I think the IB generally respects that pretty well. Because they try not to make you have to completely organize things on your own. All right, so if I look at the probabilities for these different situations, I've just filled in the gaps based on the fact that I know there are 5 green and 3 white to start. If I pick a white, I'm down to 2 white out of 7 in total. Complementary is 5 out of 7 for that probability. If I pick a green, they've already told me that I'll have 4 greens left out of 7 in total. The complement for that is 3 out of 7. So it can be really snappy to fill in those missing probabilities. So now they say find the probability that exactly one of the selected balls is green. And so anytime you're doing this, you just have to map out which branches of the tree correspond to that outcome. And so the two that I've put dots beside are those branches. I could either go this way and pick a green and then a white, or a white and then pick a green. So the probability of exactly one green is going to be equal to 5 out of 8 times 3 out of 7 plus 3 out of 8 times 5 out of 7. And those products are actually the same thing. So I get 15 out of 56, but I get it twice, so it ends up being 30 out of 56. And so there are my probabilities for question 2. Question 3 we've already done. So now we're on to question 4, one of your standard, here's a graph and evaluate some stuff from it. Write down the value of f at 0. So if I read off of my graph, it looks like when I have the function at 0, my y value is negative a half. Now, where I've just written the answer on my solutions, I don't have an issue with because I'm going to read that and mark it anyway. You'll notice, or hopefully you've noticed at this point, this exam's formatted a little bit differently compared to your final exam from last year and your midterm exam back in January of last year. And it's got these boxes written on each question. So the IB actually has this format they use on their math exams. And other exams. I don't want to pretend this is exclusive to math, but this is something they do on exams on what's called a structured paper. Structured papers being ones where you actually get the question booklet instead of writing in an answer booklet or anything like that. You write your answers actually in the question booklet for the most part. Now, we've talked about how the math exam's not fully structured because you do eventually write in an answer booklet. But for these answers where it's structured and in the question booklet, you actually do have to make sure you write all your work down here. I'm sure that there are some people who mark who are very generous and understanding, but in general, the IB is expecting you to write within that space. And if you don't write in that space, I think the main concern is there's not a guarantee that the work would actually have been scanned fully. So, for example, the tests, they get mailed off after you're done, and they go to some scanning center, I think in the US somewhere, where they will basically run all of our school's exams through a scanner and send digital copies to the people who mark. So if you're an IB evaluator, you might be evaluating for a school halfway around the world, and that means they're not going to physically mail you those papers and then have you physically mail them back. They load them into an online system after scanning them. They give markers access to that system, and they mark a digital version. However, if you write outside that box, you might end up writing too close to the margins of a page. The scanner might not pick it up reliably, and then that's going to pose problems. So in general, you do want to write your solutions within that box. And the reason why I put the box here for the mock is to get you into the swing of doing that for the actual IB exams when the time comes. So I'm actually going to continue writing all my solutions down there. Okay, so now I am being asked to find what is f inverse of 1. So f inverse of 1 is basically saying that I've got some point on the original function where a y value is 1. Oops. I'm writing in an x value that's not actually valid. I've got some point on the original function where the y value is 1, and I need to solve for the corresponding x value. So if I trace across from here, this appears to be the point that they're referring to. And so if I was doing the inverse and I subbed in 1, I would get a y value of 2. Then they asked me to write down the range of f inverse. Well, the range goes from, well actually, let's look at the domain of this function first. The domain goes from -2 up to 2. And the range of this original function, just for the sake of writing it, goes from -2 up to 1. Now, we've talked about the notion that when you do an inverse, you swap properties of x and y, because that's what an inverse does. It's the mapping that takes your y values and moves them back to your x values. So to that end, everything that was related to x in the function relates to y in the inverse, and vice versa. So that condition on the domain from -2 to 2 is actually the condition on our range. Right? So the range for f inverse is actually the same condition as the domain for f. And then on the grid above, sketch the graph of f inverse. So this is also really easy to do if you remember that we're just swapping x and y values. So this point here is at 2, 1. So I'm going to plot this point here at 1, 2, and that's on the inverse. I have this point here that's at 1, 0. So I'm going to switch it. It's over at 0, 1 now. I have this point here, the y-intercept, which I said was at -0 and -1/2. So its inverted version is here at -1/2 and 0. And basically, what I always recommend is just go through and find as many points that you can, these points that are actually on the intersection of grid lines. And so what you're going to want to do then is just swap their x's and y's. This last one here is actually already at -2 and -2, so even when you flip it, it doesn't go anywhere different. This one here is at -1.5 and -1, so we're going to put it at -1 and -1.5. And if I connect these now with a curve that approximates the original, I'm going to get this. And you'll know you've drawn an inverse correctly if, when you go to do this line y equals x, you graph that, and if you kind of rotate your head, it should look like it was reflected across that line. And so that's how you'll know you've done an inverse properly. Moving on to number 5, and again, I'm just going through the practice mock here and doing solutions in real time. But if there are any other requests from people, then I will jump to doing those instead. I know our volume of requests is a bit lower because not everyone is able to attend this online review. I can fully appreciate that tomorrow is a big day for some people because I think, what do you guys have in the afternoon? There's business management running in the afternoon. And then what's running in the morning? I want to say geography and something else. Possibly geography and chemistry. Anyway, while the exam schedule loads up so I can actually double check what's running tomorrow, let's do number 5. So simple log evaluations here to do. What is log base 3 of 27? So what exponent do I put on 3 to make it 27? The answer to that is 3. Log base 8 of 1 over 8. Oh, really wrote that wrong. Log base 8 of 1 over 8. What exponent do I put on 8 to make it 1 over 8? Well, that would just be -1. And part 3 here, log base 16 of 4. What exponent do I put on 16 to get 4? That's going to have to be 1/2 because I'm square rooting. And so then in B it says hence solve, and then they give me those 3 logarithms is equal to log base 4 of x. So that's done very purposefully. And please don't forget, anytime you see a hence or otherwise, it's really trying to hint to you that that you've been given information that's going to help you solve the next part. The next part of the problem might even be worth fewer marks because the part A or part B or whatever feeds into the next section. So you really need to make sure that you're looking at that closely. So here when it says hence, I'm thinking to myself, great, I'm going to use all those numbers because I see log base 3 of 27. So I know that that is 3. And then I see log base 8 of 1 over 8, so I know that that's minus 1. And then I'm taking away log base 16 of 4, and I know that's equal to a half. And all of this has to be equal to log base 4 of x. So I took the equation I'm being asked to solve and really tidied it up with the information I already had. 3 minus 1 is 2, and then 2 minus a half is going to leave me with 3 over 2. So I have 3 over 2 is equal to log base 4 of x. And so anytime I have a single logarithm is equal to a number, I should hopefully be recognizing that I can take this form and rewrite it as this. Any logarithm can be re-expressed as an exponential or vice versa. And kind of depends on where your variable is, whether that's worthwhile to do or not. And in this case it is. I need that x out of the logarithm. So what this is actually saying is 4 to the 3 over 2 is equal to x. So 4 to the 3 over 2, that over 2 part square roots it. So square rooting of 4 gets you a 2. So x is equal to 2 cubed. 2 cubed is equal to 8. So there's my x value, and I'm done. So again, hence or otherwise questions, just be mindful that what is being told to you is that that thing you just did is really important to the thing that you're doing now. All right, I said this was going to run for an hour, and according to YouTube, I started streaming 62 minutes ago. So I'm going to do maybe one more question, which can either be the next question of the practice mock exam or a request, if someone can pop that into the chat. The delay between when I can see something and when it actually happens in the video, I think, is down because I tweaked some of the settings. So the delay has gone from being, I think it was close to 60 seconds last time we did this. I think it's closer to 10 or 15 now. So if you throw something in the chat real quick, I can pivot to doing that one. Oh, I don't know why. Every time we do a review session, I get this tickle in my throat. It's not something that happens teaching in the classroom or doing extra help in any other scenario, but it's like as soon as I put this headset and mic on, my throat just decides it's given up. All right, so this question here. Oh, this one I actually remember. So let f of x equal 6x times the square root of 1 minus x squared, and the x is restricted between negative 1 and 1, and g of x is equal to cos x for x between 0 and pi. And then they say let h of x equal the composition of f and g. So they are saying that basically I need to substitute g into f and get a new function. And so then they say write h of x in the form a sine bx, where a and b are integers. And so I've got a pretty clear gut instinct that this is going to work out to involve some sort of trig identity. As soon as I see a sine or a cos, which is what g of x is, and I know something's being squared, that's where my head goes. I think, oh yeah, I can solve or simplify this with a trig identity. So let's take a look at what we have. It's normally 6 times x times the square root of 1 minus x squared. This is going to be 6 times cos x times the square root of 1 minus cos squared x. So there's my composition. But I'm being told it can be rewritten in the form a sine bx. So again, I'm thinking, okay, there are identities at play here. And I see one already, and it's under that square root. 1 minus cos squared x, I can get that from the Pythagorean identity. Sine squared x plus cos squared x equals 1. If I move that cos squared x to the other side, I get an expression for sine squared x. So I'm going to go ahead and swap that out. I'm going to have 6 cos x times the square root of sine squared x. Well, now I'm square rooting something that's squared, so those are going to negate each other. I end up with 6 cos x, and I square root something that's squared. I'm just going to end up with sine x there in the end. And so 6 cos x sine x, I can actually do a little bit of factoring here. I'm going to factor out a 3 and be left with 2. I'm going to put the sine x first, sine x cos x. Putting the sine x first doesn't change anything. However, if you then went looking into your formula book for some sort of handy identity, you would find this one. So I just rearranged it into the form that would look most familiar. 2 sine x cos x is equal to sine 2x. So I'm going to swap that out now, and I end up with 3 sine 2x. And that's the form I was looking for. H of x here is expressed in the form a sine of bx, where a and b are integers. A happens to be 3, and b happens to be 2. All right, so part B of this question says, hence find the range. So again, I see hence there. That's implying to me that finding the range is presumably easier now that I know what h of x is as a sine function. And it's true, it is. The range of a sine function normally goes between -1 and 1. But if the amplitude changes, or if there's a vertical shift, that's going to change the range. Now, I don't see anything added on at the end, so we're not dealing with a vertical shift. We haven't moved that baseline that the sine curve oscillates above and below. However, this 3 that's up front does have a part to play in what the range is. Well, okay, I just got some sort of weird error message on my screen. And so hopefully the stream is still going. It says I'm still live. Okay, well that was a doozy. I didn't see if it popped up. I've got 3 monitors running here. It popped up on only one of my monitors. I don't know if it showed up live on the stream or not. I guess I'll see if I go back and look. Anyway, as I was saying, that 3 in front changes the amplitude. So this is stretching it out more, like that. So the range used to go from -1 to 1, but here the range of h of x is going to go from -3 up to 3 instead, just because the amplitude changed. And so that's the end of that particular question, and I'm actually going to stop here. I hope for those of you who are able to tune in that this was helpful to you. Again, I know that many of you have priorities that fall elsewhere at this point in time, which I completely understand and support. I mean, it's not always easy to, I guess, prep for math when it doesn't immediately follow a weekend. And so some of you maybe wish that math was earlier. Although, having said that out loud, I'm thinking actually maybe that's not accurate. Most of you are probably quite content that math is towards the end because it gives you as much time as possible to focus on it. But it does kind of make our review scheduling a little bit wonky. And so, anyway, hopefully this was helpful to you. For those of you who tomorrow are writing geography, chemistry in the morning, or perhaps business management, which I think is the one that runs in the afternoon. Yeah. So if you're writing geography, chemistry, or business management, hope your exams go well. Those of you who weren't able to attend but maybe watch this later, I hope your exams did go well. Those exams are a bit on the longer side, with geography being like 2 hours and 45 minutes, and chemistry being, I think, over 3. So I know that there's significant papers, and I know you guys are probably pulling out all the stops to make sure you're ready. So if you came back and looked at this after, great. If you are hoping that the rest of the practice mock exam solutions will be live, just know that tomorrow I'm going to finish populating the OneNote file with them. So if you go and take a look at those, they will be there after that point. Having said that, please remember that I said we shouldn't be digging into this practice paper until you feel like you've done a substantial amount of review. This should be one of those things that you tackle to help you check that you are prepared. It's also very good to look at because this formatting is exactly the formatting that I use on your mock that you'll be writing on Wednesday. And so if you're wondering, okay, how's the exam going to be laid out, or what's the overall kind of structure, pacing of the paper, or whatever the case may be, This is a really good example. I legitimately, every time I create a new one for the following year, I go back to this template and I pull out all the old questions from the previous year and then put in new problems to solve. And so if you look through it and you're looking at kind of the general distribution of topics or how the questions scale in difficulty over time, like you want to get a sense of, okay, what is the question 10 going to look like on paper 1 and paper 2? Take a look at this practice mock. That's why I made it available to you. It gives you the clearest and best sense of what the real mock exam will look like, and inevitably what the real IB exam will look like. Except this one, again, doesn't have any calculus. So I'll leave it there. Again, good luck to you tomorrow. Don't stay up studying too late. There's just diminishing returns for that. If you stay up studying for chem or geo or business and you go in sleep deprived tomorrow, that directly impacts the productivity of your work on the exam and your ability to think and come up with creative ideas and problem solving when you're writing an exam. So be well rested, be well nourished, and good luck. And so I will see you all. Our next review session, I said, is going to be in the afternoon on Tuesday. So after your Language B exams run in the morning, on Tuesday in the afternoon, you guys can come find me. If there's enough, small enough number, we'll just work in my office. And if there's a big enough number, we'll go and steal a classroom. I hope that the attendance there will be pretty robust. We had about 6 people on the study day. 3 or 4 people. I think we maxed out at 5 during this review session. Hopefully I'll see most, if not all of you, on Tuesday afternoon. So I'll leave it there. Good night, everybody, and this will be the end of the stream.